Time. We experience it as a steady flow from past to future. We remember yesterday, live in the present, and anticipate tomorrow. But what if that flow could be bent, or even reversed? What if time travel isn't just the stuff of science fiction, but a scientific possibility? For centuries, time travel has captured the imagination. From H.G. Wells's classic The Time Machine to modern films like Interstellar and Tenet, the idea of moving through time like space is a recurring dream. But how close are we to making it real? Let's start with the basics. Einstein's theory of relativity. According to special relativity, time is not a universal constant. It dilates, slows down, depending on your velocity. The faster you move through space, the slower you move through time. If you could travel near the speed of light, time for you would pass much slower than for someone standing still. This phenomenon has been proven. Astronauts aboard the International Space Station, moving at high speed relative to Earth, age slightly more slowly than we do. It's not fantasy, it's measurable. This form of time travel is called time dilation, and it's real. So, in a sense, traveling to the future is possible. If you could build a spacecraft that travels at relativistic speeds, say 99.99% the speed of light, you could leave Earth for what feels like a few years and return to find centuries have passed. But what about the reverse? Traveling to the past? That's where things get tricky. According to general relativity, gravity also affects time. The stronger the gravitational field, the slower time flows. This is called gravitational time dilation, and it's most extreme near black holes. The film Interstellar dramatized this by placing characters on a planet orbiting close to a black hole, where 1 hour equaled 7 years in Earth time. Still, this only allows travel to the future, not the past. For backward time travel, we have to enter the realm of closed time-like curves, hypothetical paths through space-time that loop back on themselves. Einstein's equations do allow such solutions under specific conditions, like rotating black holes or massive cosmic strings. But these require exotic conditions, including negative energy or wormholes, which may or may not exist in reality. Wormholes, theoretical tunnels through space-time, could, in principle, connect different locations in time. If one end of a wormhole were accelerated to near light speed and then returned, the time difference between the two ends could allow travel from one era to another. But the challenges are staggering. Wormholes might collapse instantly. Stabilizing them would require exotic matter, a substance with negative mass. And even if one could be built, navigating it without being destroyed by radiation or tidal forces is another problem entirely. Still, the math doesn't rule it out, and where the math allows, imagination follows. Many physicists believe that quantum mechanics could hold the key. In quantum theory, particles can exist in multiple states at once. They can tunnel through barriers and appear in places they shouldn't be. Could time be another dimension we can tunnel through? Some speculative theories suggest that quantum entanglement could be linked to wormholes, forming ER equals EPR, a possible unification of general relativity and quantum mechanics. If so, space-time itself may be threaded with micro-wormholes, and time, in principle, may be more flexible than we imagine. Then there's the question of causality, the backbone of reality. If you go back in time and change something, what happens next? This leads us to the infamous grandfather paradox. If you travel back and prevent your grandfather from meeting your grandmother, would you cease to exist? One proposed resolution is the many worlds interpretation. In this view, every time you make a change in the past, you create a new branch of the universe. You don't erase your original timeline, you create a parallel one. You still exist, just in a different branch. This removes paradoxes, but introduces the idea of infinite realities, each with its own timeline, consequences, and futures. It's a beautiful and unsettling possibility. Others believe that time may be self-consistent. According to the Novikov self-consistency principle, any actions you take in the past were already part of history. No matter what you do, you can't change the outcome because you already did it. In this view, time is not like a book you can rewrite. It's a sculpture already carved. Your journey back in time is just another part of that sculpture. But even if backward time travel proves impossible, the idea changes how we see reality. It forces us to question the flow of time, the nature of cause and effect, and our place in the fourth dimension. And maybe, just maybe, that's the point. Time travel isn't just about machines and paradoxes. It's about perspective. How we understand memory, anticipation, history, and choice. We are all time travelers, moving forward second by second. What we do in that time defines our story. And who knows, in the distant future, civilizations far more advanced than ours may master space-time in ways we can't yet comprehend. They may send probes through wormholes. They may encode memories into tachyon streams. They may even loop back to observe their ancestors, us. If so, perhaps the UFOs we imagine, the dreams we have, the myths we tell, are shadows of those yet to come. Time is not just a line, it's a mystery, a canvas, a puzzle waiting to be solved, and we've only just begun to glimpse its possibilities.